In this video, we're going to cover Chapter 3, Graphing Behavior and Measuring Change. So we're going to start with some basic definitions. At this point, you know what a graph is. It's a visual representation, and in our case, we're going to be looking at visual representations of behaviors over time. Most of the graphs, if not all of the graphs that we look at in this course, are going to be all about behavior, because it's a behavior modification course. So we're going to look at sort of common ways to put together that data and how we can measure it and represent it. So I'm going to be covering a lot less detail than what's in the textbook because I'm going to assume that you know quite a bit about graphs by now. And mostly I just need you to be able to read them for this course, though I will get you to anticipate having to do something with data for your first assignment. So don't completely ignore this chapter. All right, so graphs are really useful because they make it easier for us to compare levels of behavior before and after treatment. If you have a graph that has a low bar as the before and a high bar on the after, then you can say that the behavior increased. Or if it's high and then low, then the behavior decreased. And as visual individuals, we tend to rely very heavily on sort of graphs and images because looking at a table or a chart isn't necessarily as helpful. So lots and lots of research is going to be using graphs. It's just a lot faster and a lot easier as a way to look at data. Now, there are a couple of standard components on a graph. Most of these you should know by now, but I'm going to go over them really quickly anyways. We have our X and Y axes. X is horizontal, Y is vertical. We have our axes labels, the numbers on our axes. We have data points, phase lines, and phase labels. Let's look at them as images here. So our Y-axis is the vertical, X is the horizontal. Our X-axis label here is days, so that's the numbers that run across here. Our X-axis label is daily exercise, and this one includes units in minutes. Days doesn't really need a quantifier because days itself are the units. And so then if we add in our next bunch of descriptors here, we have our data points, the little squares on here. And we can have a phase line. This is where we start getting into stuff you may not have seen before. So this phase line is a dotted line here, and these are intended to show us a change in treatment. So it's telling us that before this time period, so before day 7, the individual was in the baseline treatment. And then after day 7, after that phase line, we have a behavioral contract. So that's when there was a treatment in effect. So beforehand, we can call this the no treatment phase. So this is the pre-treatment phase. And then afterwards is the treatment phase. So the phase line divides different kinds of treatment, or baseline versus treatment, or whatever. Different kinds of treatments get divided up. So those are the basic labels that you should be familiar with, and you'll see those quite a bit in this course, and you're going to start seeing them today. Now, I've already mentioned the scientific method a couple of times in this class. And so if we want to talk about what is that method that we're using specifically for behavior modification, how do we break it down? And so this is very simplified, and it'll adjust a little bit based on what kind of experiment you're running, but the sort of rough outline of it is you're going to somehow measure your dependent variable, and our dependent variable is going to be our target behavior. So we want to see, where is the target behavior sitting? We want some kind of baseline in most scenarios. Step 2 is going to be to manipulate our independent variable. So our independent variable is the thing that we are changing. So it's going to be either some kind of environmental event or some kind of treatment that we're going to use. The researchers do the manipulating that changes that independent variable, with the assumption that our dependent variable should change accordingly. So we want to demonstrate A change in our target behavior demonstrates a change in our dependent variable because of that manipulation to the independent variable. And while we're doing this, we want to do our best to eliminate confounding variables. So the more extra variables that we can control for, the more that we can be certain that our manipulation is what's causing that change in the dependent variable. If you're doing something like a more naturalistic study, if you were out in nature, it's a lot harder to control for things, and that can introduce some uncertainty. But if you were in, say, a lab, a very highly controlled environment, then you could be a little bit more certain of that relationship between those two variables. And then step 3 here is to replicate those results. Just doing this once doesn't really tell us that that manipulation is the for sure cause of the change in our dependent variable. We want to make sure that that's what's going on. And we'll see that idea of replication as we move through this lecture here. So there are a couple of different sort of basic designs or research designs that we can look at. And these are very common for behavior modification research. So we can look at A-B designs, A-B reversal designs, and some variations on those, multiple baseline designs, alternating treatment designs, and changing criteria designs. So each of these is going to get their own slide. So let's start with those A-B designs. And so here our A is sort of the first stage, the first phase of our research. So that's usually a baseline. And then B is going to be some kind of treatment. So it's phase A and phase B. We have baseline and then we have treatment. And so because it's just 1A and then 1B, we have one round of baseline and then treatment. And like I said, we just saw, actually, go back here, this is missing stage 3. So that's step 1 and 2, but we don't have this step 3. There's no replication. And so that tells us that this isn't a true research design because there's no replication. Because we're just seeing that there's a difference between baseline and treatment, but we don't have any evidence that tells us that there's some cause, that the change in environment is what's causing that change. We can't for sure say that there's some kind of functional or causal relationship here. If we want to think about why that might be the case, if we look at this graph up here, we have sort of the number of cigarettes smoked and the number of days. So this is our baseline and this is our treatment. And there's sort of a assumed phase line here because there's a break in the graph. So during the treatment phase, they're smoking a lot more, and after that, they're smoking a lot less. So we could say that, yeah, there's a difference in the before and after because of whatever the treatment is. But what if there's something in the environment that changed that's affecting this? What if maybe the person is in between paychecks and they don't have enough money to buy more cigarettes? So at the beginning, they still had money from their paycheck, and then they're starting to run out of money, so they buy fewer and fewer cigarettes, and then they've run out, so they can't have any more until their next payday. So there are other things that might explain what's going on. So we can't assume that there's a functional or causal relationship here because we haven't shown enough evidence to say that that's the only explanation here. So if we can't rule out those confounding variables, then we can't say that there's a causal relationship. But this kind of design does still happen fairly often. And we can see it used in situations where maybe we're not interested in demonstrating that there's a causal relationship. Maybe we don't care what caused the decline in cigarettes smoked. Maybe we just want a change in that behavior by having fewer cigarettes smoked. Maybe that's good for that individual, and we could be satisfied with that. So sometimes we'll see this in clinical practices or self-management projects where you have a single individual who's trying to change their behavior. And if this sort of treatment phase, if this line stayed low for long enough, they might call it good enough and be happy with it. So maybe they don't care which factor caused it. Maybe it was the treatment, maybe it was something environmental, maybe it was something they can't even think about, but it had the desired effect, so they're fine. Our next design to look at is the AB-AB reversal design. So this is how we can modify that AB design to actually be a true research design by introducing replication. So you have your baseline, and then you give that treatment, and then once that treatment has taken effect, you remove the treatment and go back to baseline to see if behavior returns to those levels from before treatment. And then you give treatment again to see if they go back to normal. And by changing only that treatment, whether it's there or not there, and by doing it once or sort of one replication or even multiple replications, if this graph continued, if you did this multiple times, you'd have AB, 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 AB. By having this nice lineup where every time we have a phase line, every time we have that shift in treatment, there's that adjusting in behavior, we could be a lot more confident that our treatment, being present or absent, is what's causing the changes in that behavior. So this allows us to then demonstrate a functional relationship. We can assume a causal relationship between the treatment and the change in our behavior. We can also have variations on this. Sometimes you'll see something like ABC and then AC. And in that case, we would be having sort of our A is still our baseline, B is still a treatment, C would be a new treatment. So maybe if you're doing some kind of behavioral intervention and treatment B doesn't actually help. So you try and get somebody to stop smoking by showing them graphic pictures of people's lungs who have smoked, and that doesn't really deter them. So you try a new strategy, and that would be treatment C. And treatment C actually helps. Maybe by having their grandchild tell them that they need to stop smoking. That helps them stop smoking. So then we could then go back to A, which is our baseline, and then back to C, the treatment that was working. And if we see this return to baseline behaviors and then back to a drop in that behavior when we reintroduce C, then we would say that we're confident that C is causing the drop in behavior. Now, you might be able to see some potential problems with this. Some things we have to consider are, is it actually ethical to remove treatment? If you are doing something like a drug study and baseline is someone is really, really sick, and then you give them the drug and they get less sick, it's really not ethical to take that drug away to see if they get sick again. So this isn't necessarily helpful. We can also run into situations where, is it even possible to remove that treatment? If you give somebody coping mechanisms, so if your treatment is teaching someone how to manage, say, their anxiety, you can't unteach them that method. So you can't return to baseline because they now know those skills and there's no going back. And in situations like that, where they've been fundamentally changed, their behavior may not return to baseline levels. So this kind of a design isn't always possible. So it's something we have to consider if you're thinking of using this kind of a design. Next, we can talk about multiple baseline designs. And so our multiple baselines are just going to be ways that we can have sort of extra replication or different ways of replicating to make sure that what we're seeing is what we're actually seeing. Because a lot of times our goal is to find that causal relationship. And we have 3 different kinds of multiple baseline designs that we're going to talk about. The first is across subjects, the second is across behaviors, and the third is across settings. And each of them is going to be very similar in style, so I'm going to talk about the first one in a little bit more detail, and then we'll kind of briefly gloss over the other two. But our first multiple baseline design is a multiple baseline between subjects or across subjects. And so in this case, you would use 2 or more subjects who have the same target behavior. And so here, the top person, this would be person number 1. This would be person number 2 and person number 3. And we can say that all 3 of them are smokers and they all want to try and stop smoking. So we would have the same treatment. We would have the same, say, education course on how smoking is bad for them, but we would stagger that treatment over time across subjects. So individual number 1 would get that treatment, would be exposed to that course after the 3rd day. Number 2, they would get it after the 4th day, and the 3rd person has it after the 5th day. So in this case, our baseline lengths are different and the treatment times are at different places because we have our phase line showing us sort of the before and after. And in this case, we're seeing that same drop where the baseline is higher than the treatment phase in all 3 individuals, regardless of when the intervention happened. So we're saying that time wasn't affecting this, it's the treatment that's a lot more likely to be affecting them. So by having that replication, by seeing the same pattern in 3 different subjects, we're a lot more confident in that causal relationship here. If we want to talk about multiple baseline behaviors, or if we want to look across behaviors, we can look at 2 or more behaviors within the same subject. So you'll notice I've kept the same graphs, but we're going to label them a little bit different. So all 3 of these would be behaviors that are exhibited by the same individual. We're still looking at individual number 1, and at the top we might be looking at how long they're able to maintain eye contact, or the number of appropriate responses they're able to give, or whatever behaviors you want to look at. If I'm talking about length of eye contact or number of appropriate responses, this might be a behavioral intervention with an individual with autism to try and encourage some more neurotypical interactions with others. In this case, we would have different treatments for different behaviors. So maybe this time we are targeting their ability to hold eye contact. And here we're targeting their number of appropriate social responses. And here we're targeting whatever else we're going to target. And so if the behaviors change between the before and after when we're specifically targeting that behavior, then we would say that the treatment, the thing that we've changed, the targeting that we've done, seems to be helping. And then if we hop to our last of these, this is multiple baseline settings. So we're going to look at across settings. So this is going to be the same subject and the same target behavior, but in 2 or more different settings. So in this case, maybe it's a child who's in high school who has a tendency to act out in class. So this is for their math class, this is their science class, and then this is their art class. And so we intervene in that behavior. We try and get them to stop acting out in class. We intervene in the math class first. The next day we intervene in the science class, and the next day we intervene in the arts class. And in all 3, we see that drop in disruptive behavior, but only after that treatment has happened in each of those classes. And so again, we're getting replication with different settings, and that makes us more confident in the causal relationship between our intervention, between our treatment, and the change in behavior. We're going to talk briefly about the last 2 types of designs here. The first is that alternating treatment design. And this is where we have a baseline and a treatment. but we're going to do them in alternating ways. So the first day is our baseline, where children are allowed to watch violent cartoons. So that's on day 1. Day 2, we control what they watch on TV, and they're not allowed to watch violent cartoons. And we look at how much aggressive behavior they show on each of those days. So when they watch violent cartoons, their behavior is aggressive. On the days that they don't watch it, it's non-aggressive, and back and forth and back and forth. This is kind of like a long-term version of the ABAB, but just repeated a whole bunch of times. So we call it alternating treatment because we have our baseline and our treatment implemented on alternating days or on alternating sessions. It doesn't have to be just daily, but they're meant to match each other. So unlike in our ABs, if I go back here, where our baseline and our treatment might be differing lengths, we can tell that apart from alternating treatment because here they're specifying that they have to be the same length or the same duration. So similar but not identical. And for our Changing-Criterion Designs, so in this situation, we're going to have still a baseline and a treatment phase, but what makes it different from our standard AB design is that our treatment phase, that B part of it, is going to have sort of a moving target. So within our treatment phase, there's a sequential performance criteria specified. Basically, there's a certain goal that you're trying to attain, and that goal changes over time. So they are successive goal levels for that target behavior. So if you're trying to reduce a particular behavior, the example we're going to look at is how much caffeine people drink. So first would be that maybe if you have a standard of 10 cups of coffee a day, our first goal line, our first sequential performance criteria would be to, or criterion for a singular, would be to get it down to 8 cups a day. And if you can meet that 8-cup cutoff, then you are rewarded. And if you can't, you are punished, or maybe you just don't get the reward. And then once you've hit that criterion for enough time, you would then have to have, say, 6 cups a day or 4 cups a day. And so that goal changes over time. So as you meet that particular level or that particular criterion, then it would move. And so this shows us a functional relationship when our behavior lines up with this moving performance criteria. And so we can see a visual of that here, where at the beginning we have our baseline of how much coffee they intake each day. And then the first line here is saying that they want it to reduce just a little bit. And this here is our performance. So these individuals were lower than that criterion level. So these horizontal lines showing us what they were aiming for. And in this particular experiment, if they kept their caffeine consumption below that particular line, they could earn money that would be paid out at the end of the experiment. After that, so once they've hit enough days below this particular criterion, then the goal post moves down and moves down. And then they see if this change lines up specifically with when the goalpost changed. And so having multiple changes is kind of like having going back and forth between AB, but without having to go back to our baseline each time. So it would be very coincidental for somebody to happen to adjust their caffeine levels precisely to these lines and have it not be caused by these goals. So having multiple of them gives us that sort of replication and makes us more confident in a causal relationship.